I'm Nurul Hazlina from UMPSP STEM Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Welcome to the first course in the Micro-credential series, Learning Python through Slider Game Development. This course serves as an introduction to the Python programming through an engaging hands-on approach, building a game. By the end of this chapter, you will gain fundamental programming skills and understand the key game development concepts. This is the first step in our three-part Micro-credential series, followed by Micro-credential number 2, which focuses on Raspberry Pi installation and configuration, and Micro-credential number 3, which covers Raspberry Pi programming. In this course, we will integrate Python programming with game development, giving you a hands-on experience in building a functional game from scratch. First, you will learn Python through developing a slider-based game, where you will implement player movement, design enemy behaviors, and create a scoring system and manage event timing, all essential elements of interactive game mechanics. Along the way, you will apply core programming concepts such as defining functions, managing control flow with loops and conditions, and handling real-time events. By the end of this course, you will have a strong foundation in Python programming and practical experience in game mechanics, equipping you with the skills to develop more complex interactive applications. There are 5 chapters in this course. Let's go through the outline for each chapters. Chapter number 1 is Introduction to Game Development. In this chapter, we will introduce the fundamentals of game development, starting with the basic game overview, followed by an introduction to Tony IDE. You will also learn about how pixels and colors are represented in Python. The key programming concepts covered include understanding the development environment and its interface, and exploring how pixels and colors are processed in game graphics. By the end of this chapter, you will have a foundational understanding of game elements and how they are managed in Python. Chapter number 2 is Game Window and Player Setup. Now that you have an understanding of game development basics, we will move on to setting up the game window and defining the player. In this chapter, you will learn how to create and configure the game window and define and customize player attributes such as size, speed, and appearance. The key programming concepts covered include function definition and program initialization, using Python operators and expressions to control player, design, and movement. This chapter ensures that you have a playable game environment and a character that responds to input. Chapter number 3 is player movement and enemy behavior. Now that we have a game window and a player, we will implement movement control and introduce enemies. In this chapter, you will implement player control using keyboard inputs and define enemy behavior and interactions. The key programming concepts covered include control flow structures such as loops and conditions, and managing real-time movement and enemy actions. This chapter adds excitement to the game by allowing player interactions and introducing challenges. Chapter number 4 is Scoring and Game Mechanics. At this stage, we will enhance our game by adding a scoring system and refining game mechanics. In this chapter, you will implement a system to track player scores based on successful actions. Introduce a game timer to regulate the pace of gameplay. The key programming concepts covered include using variables to manage score tracking, understanding the importance of event timing in game development. By the end of this chapter, your game will have structured gameplay elements that provide feedback to the player. The final chapter, Chapter 5, Game Timing and Event Handling. In this chapter, you will implement timing mechanism to control gameplay events, synchronize actions such as enemy movement and player interactions. The key programming concepts covered here is event coordination and the use of timers in programming. This chapter polishes the game experience by ensuring consistent movement and interactions.
Hello, hi. I am Nurul Hazlina from UMPSP STEM Lab, the Faculty of Electrical Electronics Engineering, Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Let's start with chapter number 1, Game Overview, Understanding Pixels and Colors. In this chapter, we will introduce the fundamental of game development, starting with a basic game overview followed by an introduction to Tony IDE. You will also learn about pixels and how colors are represented in Python. The programming concepts covered include understanding the development environment and its interface, and exploring how pixels and colors are processed in game graphics. By the end of this chapter, you will have a foundational understanding of game elements and how they are managed in Python. Hi! In this video, we will explore pixel coordinate systems. In the digital realm, everything boils down to pixel, those tiny fundamental building blocks of images and screen. We'll unravel the magic behind pixel coordinates, understanding how they work and why they are crucial for everything from graphics programming to web design. First, let's grasp what a pixel really is. A pixel, short for picture element, is the smallest controllable element on a screen, canvas or images. Each pixel has its own properties, like color, brightness, and transparency. When you see an image or text on your screen, it's composed of countless pixels working together. Now, let's dive into pixel coordinate system, a grid that assigns unique addresses to every pixel on your screen. Let's look into pixel coordinate gridding system. In this grid, each pixel is identified by a pair of coordinates, usually represented by X and Y. The X coordinate moves horizontally, while the Y coordinate moves vertically. When counting pixel, we typically start from 0, 0, the top left corner on the screen. This is our origin point. So, the pixel 0, 0 is the top left pixel on your screen. And as we move right along x-axis, the x value increases. Similarly, moving down the y-axis increases the y value. For example, consider a pixel at 2, 3. 2 refers to its horizontal position from left, while 3 refers to its vertical position from the top. This system gives us a precise way to pinpoint any pixel on the screen, making it essential for graphics programming, game development, and image editing. Understanding pixel coordinates unlock a world of possibilities. It's the language of graphic designers, web developers, and game creators. From aligning elements on a web page to animating characters in a video game, pixel coordinates are the key to bringing you a digital creation to life. So, next time, when you interact with digital image or screen, remember the pixel coordinates working behind the scenes, guiding each and every pixel to its place. In the world of coordinate systems, there are two prominent players: the Cartesian coordinate and pixel coordinates. Let's explore the key differences between them, starting with our good old friend, the Cartesian coordinate system. In Cartesian coordinates, we begin at the point 0, 0, which is right here at the intersection of the x and y axis. Now, let's say we want to plot the point 2, 3. we move 2 units along x-axis to the right and 3 units along y-axis upward. Now, let's shift gears and dive into the world of pixel coordinates. In pixel coordinates, we are still plotting the same point 2, 3. However, instead of measuring distances in units, we are dealing with individual pixels. So, when we place our point at 2, 3, we are essentially saying that it's located at the second pixel from left and the third pixel from top. Let's do a quick comparison. Here's our Cartesian grid again. With Cartesian coordinates, 2, 3 takes us to this point. And here is our pixel grid. While in pixel coordinate system, 2, 3 leads us to this precise pixel. So, in summary, while Cartesian coordinates give us abstract position based on units, pixel coordinates deal with the actual pixel on our screen. Understanding these coordinates is crucial. Whether you are designing graphics, developing games, or simply navigating the digital world, both have their unique strength and application. So stay curious, keep exploring, and embrace the power of pixel. In this video series, we'll explore the vibrant world of colors in computer programming and discover how to harness their power to create stunning graphics, visualize data, and add life to your projects. Colors aren't just pixels on a screen. They are a powerful tool that can breathe life into your projects, enhance your user experiences, and convey information with style. Whether you are crafting captivating graphics, visualizing data, or simply add that wow factor to your software, understanding colors is a fundamental skill that transcends programming languages. From Python to Java, JavaScript to C++, and many others, no matter what your language of choice, the principle of color manipulation remains consistent. So, in this video, we'll uncover the universal concept of color representation, manipulation, and application that you can carry with you regardless of the code that you write. In the world of digital color, understanding RGB is fundamental. RGB stands for red, green, and blue. These are the primary colors used to create a wide spectrum of colors on screen and displays. Think of RGB as the building block of digital colors. Just like primary colors in traditional art, red, blue, and yellow, RGB primary colors, red, green, and blue, serve as the foundation of the other colors. Each primary color, red, green, and blue, can be thought of as individual channel of color information. Combining different intensities of this channel allow us to create a vast array of colors. For example, mixing full intensity of red, full intensity of green, and no blue gives us the color yellow. In the RGB color model, each color channel is typically represented with values ranging from 0 to 255. So, for full intensity red and green and no blue, we'd represent yellow as 255, 255, 0. Visualizing red, green, blue in 3-dimensional, we can imagine a cube where the corners represent the primary colors. All other colors within the cube are created by blending these primary colors. Mixing RGB value together in different proportion allows us to achieve an extensive spectrum of colors. It's like having a palette of light at your fingertip. In practical applications, you can often specify colors using RGB values, where you control the intensity of each primary color to create the exact shades of your desire. So remember, red, green, and blue are primary colors in the RGB model, and by blending them in various ways, you can paint your digital world with an endless palette of colors. Now that you have a grasp of RGB and primary colors, you are well on your way to mastering the language of digital color. Stay tuned for more insights into the colorful world of programming.
Hi, I am Nurul Hazlina binti Nordin from UMPSP Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Chapter number 2 is Game Window and Player Setup. Now that you have an understanding of game development basics, we will move on to setting up the game window and defining the player. In this chapter, you will learn how to create and configure the game window, define and customize player attributes such as size, speed, and appearance. The key programming concepts covered include function, definition, and program initialization, using player operators and expressions to control player design and movement. Before we dive into Python for game development, let's take a moment to understand why Python is a preferred language for various applications, including Raspberry Pi programming and game development. Firstly, Python is one of the most convenient programming languages. It is simple and readable syntax makes it easy to learn and use, even for beginners. Python provides a built-in programming environment. It comes with tools like the Tony IDE and an interactive shell, which make coding and debugging easier. Python has great APIs that allow direct access to Raspberry Pi. This makes it ideal for projects that involve sensors, actuators, and automation. Python is a high-level language, which means you don't need to worry about low-level memory management. Unlike C or C++, you don't have to explicitly declare data types, such as integers or floating points, before using them. Another advantage is that Python doesn't use pointers, which eliminates a common source of programming errors in C and C++. Python supports object-oriented programming. It allows the use of classes and objects, making code modular, reusable, and easier to manage. However, there are some trade-offs. Python is slower compared to C or C++ because it is an interpreted language. So, instead of being compiled into machine code, Python runs line by line, which affects execution speed. But this also makes debugging easier and allow for rapid development. Overall, Python's ease of use, flexibility, and strong hardware integration makes it an excellent choice for programming Raspberry Pi and developing games. Let's explore its capabilities as we move forward in this course. So, Python is known for its simplicity and readable syntax, making it an excellent choice for beginners. Let's compare how different programming languages print the phrase "Selamat datang" on the screen. In C, we need to include a library, define the main function, and use printf. While in Java, we need to define a class and a main method before printing the text. Here's how it looks. Now, let's have a look into Python. Just a one simple line of a code does the job, simply as print "Selamat datang." No semicolons, no special functions declaration, just a straightforward approach. This simplicity makes Python an excellent language for game development and beyond. Before we start coding our game, let's explore the different ways we can write and execute Python programs. Python provides two main environments, the interactive shell and the integrated development environment, IDE, like Tony. The Python shell allows you to type and execute single-line commands interactively. It's great for testing small code snippets. However, for developing full applications, we use an IDE like Tony. It provides an editor to write and save scripts, as well as tools to debug and run programs efficiently. For our game development, we'll be using Tony IDE, as it allows us to write, test, and manage our Python codes in a structured way. To build our game, we need to understand how Python handles different types of data. Let's go through the most important data types you will use in this course. The numbers. Python supports integers such as 10, -5, 100, and floating point numbers. An example is when you declare player score at the beginning equals to 0. Secondly is the strings. Strings store text. In Python, we write them inside single or double quotes. Next is the list. Lists are used to store multiple value in a single variable. They are mutable, meaning we can modify them. Example, next is tuples. Similar to list but cannot be modified after creation. It's useful for fixed sets of values. For example, screen width and height. And finally, the dictionary. It is used to store key value pairs. For example, player stats, name Ali, score 50, life 3. Throughout this course, we will use these data types to store and manipulate game elements, such as the player's attributes, enemy positions, and game scores. Let's start with designing the game window. To use Pygame in our code, we need to import the library. So insert this code, import Pygame. Define the width and the height of the game window. Values determine the size of the window where our game will be displayed. We'll make the window 300 pixels wide and 300 pixels tall. Colors are represented as RGB values, where each component represents red, green, and blue, ranges from 0 to 255. For example, we'll use a bright blue color for our background. Hence, the value is 00255. Create the game window using Pygame library. This window is where our game will be displayed. We use an infinite loop to keep the game running until we decide to close it. A while loop in Python is like a repeating command. It keeps doing something as long as certain condition stays true. We do this by filling the entire screen with the background color. Same code as before. Once we have drawn everything we want to show in this frame, we need to update the display to make it visible to the player. So this is your game window now. Feel free to customize the color according to your preference. Full code is accessible here. For activity 2, we will define the player. We'll use a green square to represent the player. Add the following code after step 1.4 and before step 1.5. We need a function to draw the player character on the screen. This is the codes that are required. Python allows you to define your own functions, known as user-defined functions, UDF. UDF enables you to encapsulate reusable blocks of codes for better organizations and readability. Def keyword is used to declare a function. Function name is the name of the function you choose. Parameters are input values passed to the function. Function bodies contain the code to be executed when the function is called. Return statement is used to send a value back when the function is called. We call the function in the game loop. Add the following code after step 1.6. So, this is a player in your window game. Now, customize the player to become a rectangular.
Hello, hi. I am Nurul Hazrina binti Nordin from UMTSP STEM Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Chapter number 3 is player movement and enemy behavior. Now that we have a game window and a player, we will implement movement controls and introduce enemies. In this chapter, you will implement player control using keyboard inputs, define enemy behavior and interactions. The key programming concepts covered include control flow structures such as loops and condition, managing real-time movement, and enemy actions. This chapter adds excitement to the game by allowing player interactions and introducing challenges. Next is to set the player movement. These are the codes that would detect keyboard input and update positions of the player. This code should be inserted inside the draw player function and before draw rectangular command. A for loop is a control structure that allows you to iterate over a sequence of elements, executing a block of code for each element. For keyword initiates the loop. Element is a variable that takes on each value from the sequence. Sequence can be a list, tuple, string, or any other iterable element. This is a for loop example in Python. This is the final code of step 3. Welcome back to step 4 of our game journey. In this step, we'll delve into the world of enemies and their dynamic movements. Enemies play a crucial role in games. They introduce challenges, obstacles, and excitement. Understanding how to create and control enemy characters is a significant milestone in game development. In Python, we have a special library called random that adds a touch of unpredictability to your games. With import random, you can tap into the power of randomness. This library is your go-to for generating random numbers, making games more exciting, simulating real-world scenario, and adding an element of surprise to your Python projects. With random, you can add unpredictability to your programs, making them dynamic and engaging. Imagine creating a game where the enemy's movement or power-ups are unpredictable. That's the magic of random. Add this code below import pygame. The enemy will be represented by a red square that falls from the top of the screen. Add this code below draw player function. Let's break down the code that creates and set up our enemy. In this code, we are creating the enemy character, giving it attributes and positioning it within our game environment. First, we define the color of our enemy character. It's red in RGB format, represented by 25500. Next, we declare global variables for the enemy's position and size. These variables x_e, y_e, enemy_width, and enemy_height will be used throughout the code to control the enemy. We set the initial size of the enemy to 20 pixels, both width and height. This determines the character's dimension. Now, let's talk about enemy's position. We use random, rand_it, 0, width minus enemy width, to set up the initial x coordinate. This places the enemy randomly within the game width, ensuring it doesn't go beyond the screen. Finally, we set the initial y coordinate of the enemy to 0. This means the enemy starts at the top of the screen. As the game progresses, we'll update the coordinate to make the enemy move downwards. Remember, this is pixel coordinate. With these initial attributes and positions, our enemy character is ready to take its place in the game world. Stay tuned as we bring the enemy to life with dynamic movements in the next steps. Let's dive into the details of this function. First, we access global variables that we previously defined. This includes the enemy's position, dimensions, the game's width and height, and the enemy's object. We create the enemy character using pygame_rect, a function that represents a rectangle. A rectangle serves as our enemy character. Now, let's animate the enemy's movement. We check if the enemy's y coordinate is within the screen height. If so, we move the enemy 5 pixels down. If the enemy goes off the screen, we reset its position. The y coordinate is set to 0, positioning it at the top of the screen, while the x coordinate is randomly chosen, allowing the enemy to reappear at different horizontal positions. The final step is to draw the enemy on the screen using Pygame Draw Rect. This function paints the enemy rectangle with the red color we defined earlier. With the Draw Enemy function in place, we are now able to see our enemy character in action, moving down the screen. Stay tuned as we continue to add exciting features to our game. Now that we have defined the Draw Enemy function and set up our game environment, it's time to introduce our enemy character to the game loop. In this step, marked as 4.4, we seamlessly integrate the drawing enemy function into our game loop. In step 1.6 before, we begin by filling the game screen with background color. This clears the previous frame, preparing the canvas for our next move. As we are creating a complete game experience, we continue to draw our player characters on the screen using Draw Player function in step 2.3. Now, the exciting part of step 4.4. We call the Draw Enemy function right here within our game loop. This is where our enemy character with its defined color and movements come into play. To ensure the game runs at a manageable pace, we have added a small delay using pygame.time.delay50. This controls the speed of the game, allowing for smoother gameplay. This is how the initial codes looks like. Now, make the enemy into a circle. Feel free to explore Pygame library at the pygame.org.
Hello, hi. I am Nurul Hazlina binti Nordin from UMPSP STEM Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdul, the instructor for this course.
Chapter number 4 is scoring and game mechanics. At this stage, we will enhance our game by adding scoring system and refining game mechanics. In this chapter, you will implement a system to track player scores based on successful actions and introduce a game timer to regulate the pace and gameplay. The key programming concepts covered include using variables to manage score tracking, and understanding the importance of event timing in game development. By the end of this chapter, your game will have structured gameplay elements that provide feedback to the player. Control flow determines how a program executes instructions. Understanding this concept is crucial when working with digital input and outputs, as it allows your Raspberry Pi to make real-time decisions based on sensors data or user interaction. In programming, control flow is managed through 3 types of control statements, which are sequential, conditional, and iterative statements. Let's go through each one with a flowchart example. The first type of control statement is the sequential statement. This is the simplest form of program execution, where instructions run line by line from top to bottom in a predefined order. For example, consider turning on an LED, waiting for a second, then turning it off. The program follows a structured sequence without any decision making or repetition. Sequential execution is the foundation of all programs, ensuring that each line of code is executed in the correct order. The second type is conditional statements, such as if-else, which allow decision-making within a program. This is where the program checks a condition before executing specific instructions. For example, if a button is pressed, turn on an LED, otherwise keep it off. Conditional logic is widely used in real-world applications, such as security systems, smart home automations, and sensor-driven responses, where actions depend on certain conditions being met. Conditional statements like these if-else help us make decisions in our code. If a button is pressed, we can turn on an LED. This technique is useful for interactive projects like the smart home automation system and automation. Learning to handle this effectively enables more complex interactions between hardware and software. The third control statement is the iterative statements or loops. Loops helps execute tasks repeatedly without needing to write the same code multiple times. For example, we use a loop to make an LED blink continuously, turning it on, waiting for a second, turning it off, and repeating the process. Loops are essential for automation and real-time systems like the traffic light controllers, sensor-based monitoring, and robotics, where tasks need to run continuously. Understanding these control structures, sequential, conditional, and iterative statements, is fundamental for writing efficient Python programming on Raspberry Pi. Understanding these control structures, sequential, conditional, and iterative statement, is fundamental for writing efficient Python programs on Raspberry Pi. By applying these concepts, you can develop an interactive and automated systems, enabling your Raspberry Pi to respond intelligently to users' input and sensor data. Now that we have covered the control flow, let's move on to the hands-on implementation, where we'll apply these concepts to control GPIO pins with Python.
Let's look at the heart of our game development journey. Step 5. These steps is all about collision detecting and scoring. As you'll soon discover, this is where our game truly comes to life, with elements interacting and scores climbing. Collision detection is the magic that happens when our player character interacts with the enemy character, making the game challenging and thrilling. But what's a game without a score? So in step 5, we'll learn how to create a scoring mechanism that keeps track of the player's performance. Step 5.1 is a pivotal movement in our game development journey. This is where we initiate Pygame, the powerhouse that brings our game to life. In this step, marked as step 5.1, we take the first step towards creating a dynamic and interactive gaming experience. Pygame is a Python library designed for creating video games. It provides us with the tools and functionalities to build games from scratch. And the gateway to this incredible world of game development is a simple line of code, Pygame init. This function initializes the Pygame library, setting the stage for an endless possibilities. In step 5.2, we are diving into the world of scores, a vital component in any game. Scores not only track the player's progress, but also add competitive edge to the gameplay. Let's explore how we are initializing the score in our game. First of all, what is the score? The score is a numerical representation of the player's performance in the game. It can signify success, challenges, and the pursuit of improvement. To make the score accessible and modifiable across different parts of our code, we declare a global variable named score. We initialize the score to 0, a starting point from which our players can begin their gaming journey. As our game progresses, this score will keep track of the player's accomplishments, whether it's defeating enemies, achieving objectives, or collecting rewards. Score also ignites the competitive spirit. Players strive to beat their own records and climb the leaderboard, adding an extra layer of excitement to the game. Next is step 5.3. This is where we define the collision function, the magic behind detecting interactions and scoring. In this step, marked as 5.3, we unveil the logic that makes our game dynamic and engaging. So, what is collision function? The collision function is our game's detective. It's responsible for detecting when the player character collides with the enemy character. To ensure that our collision function can access and modify essential variables, we declare player, enemy, and score as global. The real action happens here. We check if the player's rectangle collides with the enemy's rectangle. When this collision occurs, we celebrate the player's achievement. Every collision is a point earned, a scoring mechanism. We increase the score by 1 when a collision is detected. It's this simple line that adds value to every player action. But what's a score without being displayed? So, we create a text label, score X, where X is the current score. To make it look good, we choose a font size, and font color. It's your chance to add an aesthetic touch to the game. And finally, we display the score label on the screen. It's a small but essential element that keeps player informed and engaged. The collision function is our game's watchful eye, as we have seen in previous slides. It's responsible for detecting interactions between the player and the enemy. In this step, we make the magic happen. We call the collision function within our game loop right here. When the player and enemy collide, the collision function doesn't just detect the interaction, it also celebrates the player's achievement. Every collision counts. Every time the collision function is called, the player's score is updated. It's this dynamic aspect that keeps the game engaging. With the collision function in action, we are now tracking player accomplishment and adding an exciting dimension to our game.
Hello, hi. I am Nurul Nordin from UMPSP STEM Lab, the Faculty of Electrical Electronics Engineering, University Malaysia Pahang Al Sultan Abdullah, the instructor for this course.
Chapter number 5 is game timing and event handling. In this final chapter, we will fine-tune our game's timing and event handling to ensure smooth gameplay. In this chapter, you will implement timing mechanism to control gameplay events, synchronize actions such as enemy movement and player interactions. The key programming concept covered is event coordination and the use of timers in programming. This chapter polishes the game experience by ensuring consistent movement and interactions.
Activity 6 is a crucial step in our game development journey. In this activity, we'll explore the art of implementing a game timer. A game timer isn't just about measuring time, it's a dynamic element that can add excitement and challenge to our game. A game timer plays a vital role in setting the pace and creating a sense of urgency. It can be used for time-based challenges, creating suspense and enhancing gameplay. In this activity, we'll dive into the mechanics of creating a countdown timer. We'll learn how to start and manage a timer, display it on the screen, and utilize it to set new objectives for our players. With a game timer, we can elevate the game experience, bringing new layers of depth and excitement to the adventure. It introduces the element of time as a factor for success. We'll also explore the visual aspect of the countdown timer. It's not just a clock, it's an integral part of the game's interface and aesthetics. We'll design it to fit the game's theme and style. As we progress, we'll unveil the magic behind managing time in our game and how it transforms the player experience. In step 6.1, import the time libraries to access the necessary functionalities. Put it on top of the code with the other libraries. We start by initializing the start time variable. It captures the current time, becoming the reference point for our game's time management. Timing is everything in the world of gaming. It introduces a sense of urgency, deadlines, and creates time-based challenges. It's the invisible force that adds excitement to the player's experience. As we embark on time-based adventures, we need a way to manage the time's state. We start with game over, initialized as false, signifying that the game is not over. With these variables in place, we are ready to control time and creating thrilling time-based challenges in our game. Next is to look into the timer function. The timer function is our timekeeper. It tracks the elapsed times, displays it on the screen, and decides whether it's game over. We'll start by calculating the total time that has passed since the game began. It's a fundamental part of time management and sets the stage for time-based challenges. Time is not just a number, it's an element on the screen. We create a time label, select a font, and display it at the top center of the game interface. The timer function also serves as our game over judge. When the elapsed times surpasses 30 seconds as being set here, it signals that the game is over and returns true. If, however, the elapsed times is 30 seconds or less, the game continues and false is returned. It's a dynamic way to keep players engaged. With the timer function in place, we are ready to manage time, create challenges, and set the conditions for victory or defeat. Next, step 6.6 is to modify the original loop of while to while not, game over. In our journey to master time-based challenges in our game, we have reached step 6.7. This step involves calling the timer function, a key element in managing the game's time. Let's explore why this step is vital to our time management. The timer function is the guardian of time in our game. It tracks time, displays it on the screen, and decides when the game is over. In step 6.7, we put our timekeeper to work. We call the timer function within our game loop right here. With the timer function in action, we introduce time as a dynamic game element. It's not just a clock, it's a challenge, a countdown, and a game-changing force. As we call the timer function, it dynamically manages game over condition. When the timer exceeds 30 seconds, it signals the game over, adding a sense of urgency and challenges. With step 6.7, we are embracing the power of time in our game. It's time to create thrilling time-based challenges and adventure. This is the initial coding. Look at the time, it is counting up. Now, for the next exercise, change the time to become a countdown timer, as shown here. As we call the timer function, it dynamically manages game over. With the timer exceed 30 seconds, it signals the game over, adding a sense of urgency in the challenges. We define two color constants, dark blue and white, using RGB values. This color will be used for background and text. Add the codes after the while loop. Make sure they are outside the while loop. The screen.fill function is a function that fills the entire screen with dark blue color, creating a background. In this phase of our game development journey, we enter the game over moment. It's here that we display the game over message and the player's final score. The step is about recognizing the player's achievement and concluding the gaming session on a high note. The game over message is a crucial element in concluding the time. It signifies the end of the player's journey and adds a sense of closure to the gaming session. In step 7.3, we display the game over text on the screen. It's a simple text, yet a powerful way to acknowledge the player's effort and signal the conclusion of the game. But we don't stop there. In step 7.4 is where we recognize the player's achievement. We display the final score, providing feedback on their performance. With the final score displayed on the screen, players can see the results of their efforts. It's a moment for reflection and celebration of their accomplishments. As we approach game over moment, we add depth to the gaming experience, celebrating the player's journey and achievements.